All right, I'm going to go ahead and get started. That's right, that's why we need 5G. Vector signal transceiver, is that a bingo if I say that word? Okay, so I'm Brian Powell. What do I want to say about me? So I used to work for NI a long time ago, worked there for 26 years. And then I went on to another couple of companies that I'll also talk about during this presentation. Because all of that has influenced what I think about software engineering and developing software. And so I want to kind of reflect on what I've experienced with software engineering for the last 30 plus years. For those of you who are on the LabVIEW R&D team, a few of you, I hope this resonates with your experience, because that's where some of this came from. I'm a certified LabVIEW architect, and then I'm also a LabVIEW Tech Emeritus, which just means I'm old. And then I recently started my own company. So the fourth place I worked is this. I just decided to start my own company, and so that's literally happened in the last couple of weeks. And so I'll actually, the goal of my company is to apply these software engineering principles and help mostly NI customers do better software engineering. And so anyway, so that's coming, or it's in place, and just really trying to get started. Let's see. So Fabiola, I don't think is in here. She's got another presentation. Wrote a blog post a year plus ago about our giants are female. Basically just call out that there are some amazing women leaders in computer science and technology. And so she proposed that presenters put a slide at the beginning of their presentation to pick a particular female leader in technology. And so I chose Margaret Hamilton, who actually coined the term software engineering back in the 1960s. She was part of she was working at Lincoln Labs and then Draper Labs, worked on the Apollo software. And then as part of the Apollo software, of course, there's a lot of concern about whether the software is going to work correctly as it flies men to the moon. And so she put a lot of thought into what is the software engineering process. We need to treat software development as not just an art, but an actual engineering process. So she's still alive. She's still in her 80s. That's actually a picture of when she's, 81 or 82. I think it looks awesome. Lego, you actually created a minifigure of her, of a handful of maybe 6 to 10 women leaders in engineering. So I thought that was pretty cool too. So anyway, she's one of the giants, I think. Okay. So, anybody know who that is? Yeah. So I was much younger when that picture was taken. I had hair. That was the first year or so I was on the LabVIEW R&D team. That big bookcase in the back contains the Stack Overflow of 1988. There's also a phone with a wire there. And then a floppy disk. And some 1/4-inch cassette tapes. And there's a digital multimeter, which was my Ethernet debugging device. So anyway, this is where I got, I graduated from the University of Texas and then went to work for National Instruments. So it was my first real commercial job. And so, here I'm on a team of about a dozen programmers working in LabVIEW R&D. There was a front panel room with about half a dozen. There was a block diagram room, that's where I sat, half a dozen of us. Deborah is probably who's sitting in the back, was in the front panel room. So she's another old timer, but she hasn't aged a bit, unlike me. So I learned all about software engineering working in the LabVIEW R&D team, I understood that software engineering is that orange Tupperware bowl right there. So that's kind of a folkloric thing. Who knows the story about the orange bowl? What's what is it particular about our source code? Yeah, that's our mutual exclusion algorithm for source code control system. So we just had a server where we copied a file server where you copied the latest source code. And you didn't want multiple people trying to write to it at the same time, so whoever had the orange bowl had the rights to copy up to the master source code. It had a lid. That was the one element queue to get in line to get the bowl. If you had the lid, you would get the bowl. The only other thing of note in this picture, I actually tried to find the orange bowl. I think it's in the NI archives where things go in, but they don't come out. It contains here double stuffed Oreos, which it never did in real life, but double stuffed Oreos did fuel the LabVIEW R&D team for the first couple of years. So that's why they're in this historic picture that Jeff sent me. Okay, so that was, my early career. Things evolved, fortunately, over time. As the team got bigger, we changed the process. We actually started using a source code control system. So things did improve over time. And so one of the things that, I kind of figured out is that, you do have to actually pay attention to the software engineering process, how your team is developing software. And I think the best way to think about it is it's another engineering problem. Okay, we have a particular problem, what are we going to do about it? And then, brainstorm, ideate, and come up with proposed solutions, try them out, test them, see what's going to work, and apply something, measure it, and keep doing that as an infinite loop. So one of the approaches that we took at NI, at least when I was there, is to make the process changes reactive as opposed to proactive. And that may seem counterintuitive, right? Oh, shouldn't you be ahead of all these challenges that you've got? The other way I think of it is like, you ever have that manager that you can tell he just read a book on management and he's trying to apply everything, right? You've had that boss, right? You can tell. It's like, oh, isn't that cute? You just had your management training, didn't you? Well, I will, you can provide support without removing responsibility, please. But especially as the LabVIEW team grew, from a dozen people to hundreds of people when I left, how do you actually get a couple hundred people behind a process change? And so my approach and my theory is that it's more effective if you let them suffer some pain. And then think about what is the best way to solve that particular painful problem. And then apply a very surgical fix-to-your process that relieves that pain. And because everybody is suddenly motivated to get rid of the pain. Right? So, an example from my LabVIEW days is there used to be, well, actually, let's talk about the orange bowl, right? There were times when we'd go home on a Friday, LabVIEW was working fine, and Monday morning come in, find out that Jeff had submitted all new code, and everything was broken, nothing worked. So that was an example of how do we put a process in place that at least discourages that from happening. And so that's where things like the orange bowl, and actually we kept a log, there's a notebook that went with the orange bowl, you wrote down what your changes were, so you know who made them, why they made them, things like that. As we went further, we started writing up these more like specification documents that talked about what problem we were solving with the feature, and added things like localization issues or installation issues or things like that you actually had to think through. And that was all in the result of having failed at something in the past. And so over time, you got the team on board with doing the process changes because, we'd have these lessons learned meetings. We call them postmortems, but, the proper term is lessons learned. And that's what we've discussed. What are we going to do to fix this? And so that, to me, it was a very effective way to get, 100+ people behind your process changes. Much better than, oh, I read a book that says that we should use agile development. And so therefore, that's going to make us go faster. Because I've seen that fail. I'll talk about that a little bit later. So the next place I worked was Athena Health. This building is, where am I? It's a little bit that way, it's about a mile that way. It's an old City of Austin power plant, built in the 1950s, and then it shut down in the 1989, sat empty for 20 years except for the occasional concert or haunted house. And then they repurposed it into a very nice office space. And Athena Health, which is a Boston-based healthcare company, moved in. I actually started a little bit before they moved in here. So a really cool place to work. We'll talk a little bit about what's happened to Athena Health as part of software engineering. So one of the, actually maybe I'll go there now. So Athena Health was one of the most amazing places I ever worked for the first 2 years. I was there 4 years. First 2 years, really amazing. And then, healthcare got disrupted when Donald Trump got elected, just because nobody's buying anything in healthcare because nobody knows what's going on in healthcare. So if you sell healthcare products, it's a time to panic. So they had 0% revenue growth when they're used to 30% revenue growth. Stock price tanked, activist investor got involved, CEO got ousted. What else? Oh, then they got taken private at maybe 75% of what they said they were going to be acquired for. And then they had layoffs and stuff like that. So bad things happened. So the second 2 years were not quite as good as the first 2 years. So in the middle of that, they hired a new CTO whose job was, like the software that Athena Health ran was, we believe, literally the largest Perl program in the world. 11 million lines of Perl code, which is like a scripting language. 5 products in one, and literally used the largest servers that we could buy. We ran our own data centers. So each server had, I don't know, maybe 16 cores, 768 gigabytes of RAM, which was as much RAM as you could put in. Big disk farms, big Oracle databases, things like that. So the CTO was hired because, you can't add features if you can't make the computers any bigger or make them run any faster. So he was doing this, what we call Platform 2.0, basically a microservice refactoring decomposition of that big product. Kind of related to Athena Health's problems is they still haven't released any part of that Platform 2.0 thing. Because the CTO was great at vision, but not very good at execution. And so one of the examples is that and this is a $1.2 billion company, 6,000 employees, of which 12 to 1,500 are in engineering. Many dozens of development teams, and across several different sites. And a rule came down that all Scrum teams shall consist of 3 developers. And we questioned that, because we had teams of 5 developers and 4 developers and 6 developers, and they were all about that size, but they weren't all exactly 3. And so we pushed back, especially the Austin leadership. We asked questions. Why? Well, that's an example where, you read an article that said that small Scrum team is better. So when we questioned it, we were given an article. Actually, go read the article. It says 3 to 7 developers, but the rule was 3 developers. And there was even the question of, well, what if we don't have a multiple of 3 number of developers? And it's like, well, you need to solve that problem. So you can, like I said, it used to be one of the best places I ever worked. So that's also one of the reasons that I and the rest of the awesome leadership got laid off in late 2017, because we weren't as aligned with the CTO's wishes as he would like. Okay, so that's an example of, again, coming back to this reactive, if there's a real problem, solve the problem. But there wasn't a problem with 4 developer scrum teams or 5 developer scrum teams. Another example was it was mandated you had to have a certain higher level title or above to be a scrum master. And we had some great 1 year, 2 year people that were great scrum masters and enjoyed the role, and we had to go in and tell them that you can't be a scrum master. Right? So again, it was here are rules that are trying to, somebody read a book, said it was a good idea, but it wasn't clear what problem we were actually solving. So again, coming back to that initial thought of treating software engineering as its own engineering problem, I think that's where you need to think about, are we really solving a problem here? The other piece of that, as I alluded to, is you should actually be open to criticism about your process, about what you're doing, how you're doing it. So I've always tried to be very welcoming of dissent, because I don't believe that I always know what is best for a team. The team knows what's best for the team. So I also believe very strongly in giving autonomy to my teams and let them solve their own engineering problems without me issuing rules. Now there are times of crisis, which I'll talk to about in my next company that I'll talk about, where you do need to take a heavier hand, if there's a real challenge in front of you. But that doesn't mean you don't listen. It doesn't mean that you don't, gather input and try to arrive at a good solution. But sometimes you just have to move. Okay. So next place I worked, I started here December of 2017, a place called The Zebra. This is 2 blocks, maybe 1 block that way. We had the top 2 floors of a nice building. There's Lady Bird Lake there. There's downtown Austin. It's the 21st floor here. We had our own barista. The receptionist doubled as a barista, because there wasn't that much to do at reception. So we had a coffee bot. You ordered your coffee online, and you get a notification when it was time to go pick up your coffee. Not quite as robotic as the Brigo downstairs, but if you haven't done the Brigo, you should use the robotic coffee maker down here. There's an app for it. Let's see. So they were a 100-person startup. It's cloud-based. It's basically an online car insurance marketplace, trying to disrupt the insurance industry, which is a very kind of backwards, from a technology perspective, industry. In the U.S., it's 50+ different jurisdictions. Every state, and the D.C., it has their own rules and laws about insurance, so it's very complicated. You end up with some big nationwide insurance companies and a bunch of mom-and-pop insurance companies. And so there's a lot of API calls to insurance carriers. It's a consumer app. You're trying to sell car insurance to everybody in the U.S. that has a car. So being a consumer website, it's gathering all of this data about you and putting it into a big data warehouse, using machine learning to figure out how to best monetize you. So it was a little creepy at first, but it was actually getting a whole lot better when I as I progressed there. And they were, like I said, they were a startup. And the reason they hired me is to kind of help them grow up out of startup phase. I'd been at bigger companies, and so when I first got there, I used to say that surrounded by dumpster fires every day. We were deploying new code 3 times a week, Monday, Wednesday, Friday. Usually something would go wrong with the deployment, and so you'd spend all day of Monday, Wednesday, and Friday fixing what you just deployed, which gave you Tuesday and Thursday to write new code to put out in the next time. They had this nice roadmap, year-long roadmap, against which they were making no progress whatsoever because they were always fighting fires, always trying to keep the website working. So one of the things that I did was slow down. Like, we're going so fast that we're making mistakes and we're not taking the big picture of we've got some big challenges in front of us that we need to address. So I slowed down the deployments to 1 day a week. That also gave us a chance to have QA participate and test before things went to production. It let us plan at a greater than 2 day level. We started doing monthly planning. What are we going to do this month? And we deploy every week. I actually tried to push to deploy every other week, but that was too slow for a lot of people. But that had a big impact. It was just like, rather than just like always, we've got to go fast, always got to go fast, which is the startup mentality. It's like, well, you're going really fast, but you're not getting anywhere. And so by slowing down, we were actually able to make a lot more progress. And we were making really good progress on this year-long roadmap, that year that I was there. The other piece of that puzzle is when I'm surrounded by dumpster fires, my attitude is, okay, well that happened, now let's go forward. How do we just go forward rather than a blame culture of like, how did that happen? How could you have missed that? How could you have written code so badly? There was, especially at a young development team, and they took on a lot of that anxiety to things. And that, I felt, made it a negative culture when that happened. And some of that came from outside the engineering team. Like, oh my God, the website is down for half an hour. One of the things that I used to say to my boss that he did not appreciate is that the Zebra was the first place that I worked where the products couldn't kill people. Because in National Instruments, as you know, the products can kill people. In healthcare, even though it's electronic medical records, you forget to show a patient allergy or something like that. You can kill a person. So, both NI and especially Athena Health had, crisis. If there was a crisis, there was a swift and effective response. And at the Zebra, there's some people who felt like this was even more urgent. People can't buy car insurance for half an hour. Oh my God, the sky is falling. But, and sure, you want to fix that. But it's also like, I also don't want to, I need to hunt somebody down and fire them for something going wrong with the website. Like, I don't want that. To me, it's just like, let's just go forward from here. Like, my attitude when I saw these dumpster fires, like, let's look how much better we can make this. From a software engineering perspective. It's an engineering problem, let's just keep working on it. Let's just continuously improve. So I think those were both really good attitudes to have at a startup, especially that company really needed. So like I said, the lesson learned here is you want to be able to experiment with new ideas. Some of the things we tried at NI, at Athena Health, at the Zebra, didn't quite work right. We thought we were making things better. It didn't work, so we would try and fix it again. We'd get new information, new measurements, fail, we might fail, learn something, and go try and fix it again. And so that's my attitude then, that led me to software engineering, that's its own engineering problem. That's also now what I'm going to be doing with my own company. So I actually want to open it up for some conversation about this topic. So I actually want to find out from people, what are some of the things that you've seen that are engineering problems or software engineering problems in your environment? What have you done or what have you not been able to do to address those? So, somebody throw out an example of something you're facing or have faced. Yeah, Rick.
So balancing delivering new functionality over code health is a constant issue of finding the right balance between those things. You can polish your code too much and not get anything done, or you can throw things together and have terrible quality. So there's a constant struggle there. There's no answer, it's just a lot of it is acknowledging the problem and making the trade-offs consciously.
Yep, that's a really good point. So it's basically balancing the, I've got features to get out and the quality part where I could work on those features for 6 months and they, make them incrementally better, but at what point do I just decide that's good enough and move on to the next thing? I face that.
The feature itself, it's the code that implemented the feature. How much do I polish the code?
Yeah.
Not really delivering anything immediately, but to make my job next month easier.
Ah, I see your point. So not just the feature itself, but the code that implements the feature.
Right. It's long-term code health versus quick velocity.
Yeah, the maintainability of code. Yeah, one of the things that I often say, as you know, is that I have shipping code in LabVIEW that I wrote when I had hair. When I was that age, it's still shipping, right? And it's not that I was this genius computer scientist, it's just that, I wrote it in such a way that it was just like, hey, it's nice, cohesive, simple to understand, code that just doesn't need to be rewritten, right? It works fun. And so, when I wrote that code, I wasn't thinking that it would still be shipping 30 years later. I mean, I went to NI just thinking I'd worked there for a couple of years. Hey, this is a kind of an interesting LabVIEW thing. I don't know if anything will ever come of it, but I also faced that a lot at the Zebra. When I first started at the Zebra, most of my engineering team was what we called not traditionally educated in computer science. So a lot of people who were doing software development as a second career, like coming out of a coding boot camp, for example. Some people who had just picked it up on their own. So one of the things that I did is what I call hired some grown-ups. Like I hired my former boss from Athena Health to come work for me at Zebra because he wanted to be an individual contributor. And I knew he was a good software developer. I knew he'd be a good mentor. I knew he'd be a good leader, technical leader on my team. And that was an example, that I think the answer, the way you solve that is you have somebody who's got experience, who's just seen it enough times to say, this needs to be written in a more maintainable way, or this is good enough, we need to move on and work on some more important priorities. And so I think experience is a big piece of that. So I added several good senior developers that then were able to take my existing software team and really lift them up and make them better software developers. That's a good example. What else? What are some other examples that people have seen of software engineering challenges on of how their team is constructed or how they're operating? Yeah.
I work with an IT team that builds a database that I use with my code, and it's almost the most important subcomponent of my code is this database, except they report to a completely different management structure, and so their priorities never match the priorities of my group. And trying to negotiate that and get the cycles out of them to fix bugs or add features has been very difficult.
What have you tried?
Just, bringing snacks to meetings.
So just to repeat it for the cameras, it's your team is dependent on another team that has the database, and reports to a management team. And so you're going to have limited influence over features, bug fixes, whatever that this other team is responsible for. How many people face that in some fashion or other at their company? Yes, I even see some NI people raising their hand. And snacks. Bring snacks to me.
There's a couple of different companies. That can be the product you're using, a library,
Mm-hmm.
and some you have to be company selected.
That's right. Yeah, it could be even outside your company. How do you?
Now, what influence do I have on Microsoft or National Instruments itself?
Right.
Whatever is wrong.
Right.
Yeah, you full support.
Yeah, right. Microsoft.
So, I think the outside the company thing is maybe a different answer than inside the company. Certainly inside the company, one of the things that I found effective is, somewhere, maybe it's at the CEO, but somewhere there's a place where somebody's responsible for solving a business problem. So in John's case, if I need to be able to put data into a data warehouse, say, and provide information so that some business analyst can make some business decision that's going to impact the way the company's running, somewhere there's a VP or a C-suite person that is responsible for making that decision based on this business data. But if I can't get the data there, then, so suddenly I've maybe got an ally of like, if you want your problem solved, you need to help me solve this problem down here. So a lot of times it's finding the right person that actually can unblock those sorts of things. And because the way most businesses operate, it's all about the business decision making. It's not always the technical decision making. And so if you can find it's going to we're not able to solve this $1 million problem if you don't let me write this piece of information to the database. It's often easy to get that unclogged. Once somebody sees the real expense from a business perspective. But it is a challenge. And then, obviously, if I have a vendor, if I'm a giant phone manufacturer and I want National Instruments to do something, that's a lot easier to convince NI to do something than if you're not. So yeah, it's kind of a leverage thing at that point. And then that may mean that you go with a different vendor. I don't know. What are some other examples? Does any of this resonate with you and your experience? That's right.
I come from an academic world, and twice I've been brought in to fix or to help with software that was really misdesigned or not designed from the beginning by scientists who didn't understand computers, talking to programmers who didn't understand the science. And then the programmers left, and I sort of walked in, and they said, oh, you know something about both. You can help us fix this. And I struggled. And at a certain point, not too many months before, I said, we are starting over. I threw out everything, and I started writing the documentation for what they needed. This was the first time I understood the lessons from the 60s, write the documentation first.
Yep.
And I ended up with something that worked. That something they said, this is really wonderful. And it wasn't all that great, but it worked.
Yeah.
Yeah, but you had a prototype to start with.
Huh?
You had a prototype system that you had to make better, right?
Yeah.
So it was easier to write the documents.
I abandoned the prototype.
Yeah, you
The
abandoned the
prototype-
implementation, not the requirements.
So just to
The
summarize,
requirement, there
One-
was nothing written anywhere.
The code was the requirement.
So-
Well, you can deduce the
No, what the
requirements.
requirements were to gather the data to control this equipment, to allow me, the experimenter, to figure out where this, how to test humans, to identify where in the dark the sound is coming from. That's all abstract. I had to help them do their abstract thing, but I did it in a way that was totally different from what they were doing, because what they were doing didn't work.
So this is a very common scenario where, raise your hand if this rings true. Say you're working on a project, like you're maybe a mechanical engineer, electrical engineer, you're hired. Hey, there's this LabVIEW thing, it's easy, just write a little bit of code. And then over the course of a year or two, this turns into mission critical code that isn't really important to the company and has to work all the time, right? Anybody seen that before?
That's managing customer expectation problem also.
Well, if you say you're a little startup and you don't know where your company's going, and then suddenly you get some customers and it turns into a big.
A little bit different, what you just
So-
mentioned. So they expect that this can be done in roughly 2 weeks. But if
Yes.
you come and realize, this whole thing has to be written and it will take 2 months. And then.
So yeah,
and
LabVIEW
then-
is easy, it should be able to do something in 2
Absolutely,
weeks.
yes. And it's almost working already, and you go and, like you said, you see that.
Well, I'm not into his example yet, but yes, yeah. So then, it's like, what do you do about it? In Robert's case, it's like, let's throw away this prototype and build it for real. Now that I know what I'm doing, let's really build it for real. In fact, that's why I was hired at National Instruments, is LabVIEW 1 was the prototype. We threw it away, and we started working on LabVIEW 2.0, complete rewrite of all the source code. Like, I was only allowed to look at the LabVIEW 1 source code once. Because that was like, really, we are throwing away the prototype. We do not want any of that code to move forward. And even looking at the LabVIEW 1 source code, it was a big printout, like this, and I had to thumb through and find the file and the line number. But that's kind of a whole question on refactoring. Sometimes you can just refactor the prototype into a good system. Sometimes you just have to throw it away. And that's a judgment call, I think, based on experience of, knowing, if you're just really, every change you make seems to be introducing a new bug, that's a pretty good indicator that you just need to throw the whole thing away because, in your case, you didn't understand the intent of the original programmers and there's nobody to go ask. So the way you think the code works is not always how the code works. I certainly have seen a lot of code like that.
And it was the blind leading the blind. The experimenters knew what they wanted to do, but they didn't know how to tell the programmers who didn't understand what they wanted to do, how to do it.
Right.
And so, they said, oh, well, we'll just do it this way.
Yep.
And it didn't.
But, another example, this is a customer I had several years ago, where this company had built two-way radios and a lot of different models, very similar but different models. They ended up with 31 different testers for these two-way radios. What would happen is, okay, here's a new model, and it would typically take 6 months to set up a new test system. So they'd assign it to a test engineer. He'd take the rack that they used last time and say, well, I need to swap out an instrument or two. I'll copy the source code from that tester to make copy number 32. Make a few changes, change instruments, maybe add a new, test a new feature on this new radio. So I ended up with 32 testers and 32 flavors of the software. And so the life of a test engineer is, okay, I'm going to spend a month or so figuring out what hardware I need. I'm going to spend a month or two integrating everything, figuring out fixturing for this new radio. I'm going to spend a month developing the software, and I'm going to spend a month trying to figure out why the radio doesn't work the way that the documentation said it would. So it's my 6 month project, I'm using LabVIEW 1 month out of that. And so you also end up with, if you only use LabVIEW 2 months out of the year in separate months, you don't always think about taking the time to institute new architectures and new LabVIEW features and object-oriented design and really cool stuff like that. You're just like, how do I get this thing working so that I can get to the next phase? So as we dug into that, the decision was made that I think was a really good decision. It's like, we need to tear down the test engineering team and rebuild the people on the team a different way. So we created a hardware team, a software team, an integration team, and a project management team. And so that let the people who were doing software focus on the software. And they were very motivated to come up with a good architecture that worked across, a single set of source code that worked across 32 different products. The hardware engineers were suddenly very interested in figuring out how to not have 32 different variations of hardware. They brought it down to 2 different variations of hardware, 1 variation of software. That made the life of the integrators easier. It also let people focus on the things that they wanted to do. Like the people who really wanted to focus on software could focus on software, instead of it being only 2 months out of their year. People who really wanted to focus on hardware could do that. The people who wanted to be like jack of all trades and do the integration part, that gave them a spot. And then it also reduced the total cost of test. I add a new radio I need to test, I can get it up and running in a month or so instead of 6 months. So it's solving a real business problem, but the solution was actually tear down the team and build a team differently. And that's kind of the, if you're starting your product development with, okay, I have this engineer who's going to be figuring out both hardware and software and how to put it all together, and then over time it grows to a bigger thing, then that's where you maybe need to think, well, do I actually have the right team in place? How do I get programmers and teach them about what the end user situation is, the physics, whatever the issue that you're trying to solve is. How do you also get them talking to those customers so that they really understand how to fix it?
But look at job postings nowadays. They want you to be, not only a LabVIEW developer, but up to the machinist, electrical engineer. So they want you to do electrical design, mechanical design, if they want to do some test in the system, and software, and even make some parts yourself.
And I think as you grow, that can't sustain itself. Now, if you're a one-person company, you put on all the hats. So, Rob, what do you say?
I think what I'm hearing you saying matches with my experience, and is a difficult thing to communicate, but that is that fundamentally, at its core, software engineering is trying to solve 3 problems: a technical problem, a business problem, and a people problem. And I think that part of what makes a really excellent software engineer is someone who can understand that and sort of communicate that to the other stakeholders that help them to understand, because most of them will only see the people problem, will only see the technical problem, will only see the business problem.
Yep. So just to echo that, software engineering is solving technical problems, business problems, and people problems, right? And so it kind of reminds me, Fabiola talks about technical wealth. Instead of focusing on technical debt, let's focus on building technical wealth. Right? And there's a lot of different kinds of wealth, right? There's I am providing something that creates business value. I'm providing something that has some technical value, even if it's maintainability. As well as I'm building a stronger team. And the people that are building it are more capable, able to do things faster or more reliably, and so on. So I've really been thinking a lot lately about how, as an engineering manager, I should be focused on building wealth, but it's a lot of different kinds of wealth. And there's also the financial part that you hope that the company becomes profitable enough to do things too. But that kind of focus on wealth, I think, is a really good way of thinking about it, and not a natural way to think about things. Any other comments? Stephen?
The people aspects I find are largely a problem almost of onboarding, as far as if you grow fast, and I've seen this not just at National Instruments, but at other places, the rate of growth in any given era affects how fast you can get your culture to spread. And there's this war between bringing in more diverse viewpoints, because that makes you a much better company to be able to solve problems and recognize things that are unusual, and getting everyone on the same page. We all are using the same tools, we're all going to use the same design methodology, and that your expectations are communicated up your management chain. Because when you say, I need to fill in this piece of technical debt, and you have a manager who says, I have no idea what technical debt is, but it's not on my feature list. It takes time to get a manager seasoned enough to recognize that nature. And you can do that if you have a few managers in your system who are new and young and being slowly taught by the others that are there. This is how you manage your team. But when you onboard a huge number, and it applies at the developer level, you bring in either a completely new group that you buy, or that merges, or you simply have a huge hiring boom. Both of those lead to a moment when you've got more diversity than coherent culture. And you end up with code bases that, this group believes that test code needs to be as good as release code and is treated as a first-class citizen. And this group that says test code is a thing we have as a temporary code artifact, and we write it as each car comes up. And both models can work if everybody is consistently treating the code the same.
Yeah. So the joke I will tell myself is that you end up with LabVIEW 8.
Yes.
Stephen's point is, especially if there's a large influx of developers, there's an onboarding problem of how do you get people culturally used to how things are done on that engineering team. One of the, it's not in this presentation, I've got another presentation that's got it in here, but like the ideal structure of a team is kind of this bell curve where you've got a small number of architects that are making some of the most crucial decisions. You've got a large number of what I call the 2 to 5 year developers that are just like good, solid developers and pretty low maintenance, which is a way of contrasting it with the architects. And then some novices that you're starting to feed into this, into the being good, solid developers, right? And that's kind of the ideal. What I had at National Instruments in the early 2000s, in the dot-com bust, there was a hiring freeze, stop hiring. And then, economy gets better, you start hiring again. So I ended up with this inverted bell curve, where I had a whole bunch of 15-year people, and I had, well, I guess back then it wasn't 15-year people, but it was like 10-year people, which was, at the time, pretty strange for NI. And one 2 to 5, one like 4-year guy, and a handful of new hires. And so I needed to find mentors for these new hires. And usually you would give that to like the good solid developers, but since you didn't have those, I had to ask my 10-year people to start mentoring brand new developers who didn't know what they were doing. So that led to some friction. So while financially it's kind of hard to pull this off, my belief is that it was a mistake to stop hiring. We could have, if we'd slowed down hiring, almost make it go to 0 maybe, without stopping it entirely, that would have been good. Same thing happened at Athena Health, where in mid-2016, this is right when the the revenue went flat and the CEO was in trouble. So it was like, stop hiring. And so for 7 months, we were told to stop hiring. And then February of 2017, we were told in Austin, which was a team of 140 people or so at the time, you need to hire 60 developers and you're behind. And so it was like mad panic. We've suddenly got to spin up the whole recruiting system again and interviewing and all this stuff. And we're behind on features, we're behind on hiring. It's just like mad panic. And so we actually did accomplish that all the way up to the layoffs that were in October that year. So we hired like 40 people. We were on track. And then they had the layoffs. That was great. But that's an example of like somebody's not thinking here.
Well, they're not seeing your team as people. They're
Yes.
numbers on the spreadsheet.
Yeah, I think that's a case where there's a general manager somewhere who is saying, well, I just promised to the board that I was going to deliver these features, and the way that I deliver these features is I need 60 developers.
Right.
And I have budget for
You need
60.
60 seasoned developers who've already been there for 2 years.
Yeah, yep,
Are people assets or liability? That's the main dilemma.
yeah, that's,
Yeah, another thing I noticed that very frequently that when you talk to stakeholder about what it is that we want to do as a contractor, they don't necessarily know what they need. You need to kind of dig deeper to find the business goal that we're trying to achieve, because the technical person may do something, but that's actually not what you need. And often enough, if you just rely completely on what the technical person thinks that they want to do, you may just deliver what they told you they want to do, and know that's what they, not what they need. Often enough, you have to dig deeper.
Yep.
Try to go higher up,
yep,
but over.
yeah.
So
So,
what it is a business reason we're doing this.
yeah,
We're
yeah.
kind of laying something.
Yeah, echoing what Rob said of just like if you go into a company and ask them what they want you to do, if you're talking to the technical person, they may tell you the technical requirements, but you often need to dig and find what the business driver is behind that, and make sure you're addressing that and not just doing what appear to be the requirements. I think I go all the way to 9:30.
Yes. You have 5 minutes.
Okay. Any other comments? Any other, yes, John?
One of the problems I run into a lot is our test engineering group is always trying to get involved in new products as early as possible to influence the design for testability. And even though we keep pushing that boundary back further and further, I keep running into cases where some very early decision was made before even most of the design group was involved, that then impacts how we can test a product, or even if we can test it. And we often get stuck with, well, sorry that that decision was made way back then and we're not changing it, now you've got to figure out a whole new workaround. And I'm just wondering, is there any way you found to better influence that or solve that problem?
Not necessarily in the moment. So the example was, wanting R&D to be more involved, or test engineering more involved in the R&D process, so that you can design for testability, spend more time like that. So a lot of times it's like you're not involved, decisions get made, and the test department gets screwed at the end, right? So that's an example where if you can at least fix it for the next project. So the react, don't proact, one of the examples of pain that the development team felt, and it wasn't even the entire development team. It's like there was some product change. I don't know, maybe Stephen Mercer changed the color of some wire, something like that, that impacted the documentation team. Like every screenshot, every description in the manual is now wrong. And if that gets made late in the process, or without even thinking about what's the impact on documentation, what's the impact on localization, with certain changes that are made. And we put a dollar amount. I don't know if it was a color change like this, but there was some late change that caused documentation to rework $50,000 worth of their effort. So this feature / bug fix cost $50,000 of waste. And that motivated changing the process for the next version of LabVIEW to avoid that kind of waste. So we still had to waste that $50,000 because we still had a product to get out, but at least it made things better for the future. So, I think if you can highlight, what's the cost of, hey, we weren't able to test this feature, or we had to spend an extra 2 weeks to work around this thing that could have been fixed in 5 minutes at the beginning of the process. Highlighting those things, having those lessons learned meetings and being able to talk about those, I think are really valuable. At the Zebra, I faced the same thing. There was like a complete, what we call the mobile revamp. We revamped the mobile version of the website and hired a design firm and just, just like all this brainstorming, and R&D was invited to be part of that. But there was nothing, like it was all over the place. It wasn't clear what we were, so the R&D developers that sat there just decided to stop going to the meetings because they weren't any close to figuring out what they were actually going to implement. So fast forward 6 months. And then it's finally decided, okay, here's what we're going to do. And it was, really, that decision was made in the last 2 weeks of that 6 month kind of thing. Okay, now go implement this. And you're behind. And then developers are like, well, why is it that we get, it kind of all flowed downhill. Here's this nice big timeline that gets crunched because there's a whole bunch of brainstorming, and then finally it's an engineering problem, and how come you can't put it out, and how come it has bugs when you put it out, right? So that when we had a postmortem there, it wasn't just a postmortem of the engineering team. It was a postmortem all the way up to the CEO of all this decision-making process, of the design process, and a whole bunch of people that are not in engineering that contributed to an engineering problem over here. And I think that helped open the eyes of some leadership to see that they had an impact on the quality of the product that was put out. Were you going to say something?
Yeah, I was out on a customer visit, and I was there to help the test team, and the meeting started, and the test leader said, by the way, we're charging R&D this meeting. And afterwards I asked, what was that about? And he's like, oh, we keep very strict billing between all our groups so that R&D knows when they're costing us time. And that apparently had been their solution, apparently had fixed a lot of problems with, they didn't want to design something that would cause the test team a problem later because it would actually hit the budget.
Interesting approach.
Yeah.
I like that. We're out of time. I'll be up here for a few more minutes, but happy to have more discussion here or outside, whatever. Thank you very much for coming.